In this video, we will be graphing a system of two linear inequalities, and this will be basic. There'll be another video for the more advanced problems. Okay, so we're given two of these inequalities here. One of them, notice one of them is just a greater than sign, and then one of them is a greater than an equal. Recall that if you have this or this, it equates to a dotted line, and if you have less than or equal or greater than or equal to, it equates to a solid line. Okay, that was covered in a previous video. Okay, so let's look at these and see if we can graph it. So we'll graph the first one. We know we have a slope, I'll call it m, is equal to -4. I'll put over a 1 there. Okay, and that's also the same thing as 4 over -1. Okay, and my y-intercept, which I'll call b is equal to -7. Okay, for the second one, our m is equal to 3, so I'll put a over 1, and I could also call that -3 over -1 if I need to use the slope in that way. The b, which is my y-intercept, is going to be 2, positive 2. Okay, so let's go over here and graph these two lines. We'll take care of the shading in a minute, but for now, let's graph them. And remember, this one is going to be a dotted line graph because it didn't have a line underneath, and this one will be a solid line. So looking at that first one, we go to -7 on the y-axis, so that's down here, okay? And then I use my slope, -4 over 1, that would be down 4, right 1, 1, 2, 3, 4, right 1. Can't go any more that way or I'll be off the graph. So instead I'll use the up 4, left 1, 1, 2, 3, 4, left 1, left 1, here we go, okay? And that one's going to be a dotted line, so let's do that here. Dotted line for line number 1. Okay, and now let's look at the other one. We've got, in fact, let's call this one 1, let's call this one 2. Okay, so this is line number 1. All right, so number 2 will be a solid line because it's got the line underneath, it's equal to. Okay, we start at 2 on the y-axis. Okay, so 2, here we go. And then I use my slope. The first one says up 3, right 1. So 1, 2, 3, right 1. Right here, here, there. And then I could use the -3, -1 to go down 3, left 1, down 3, left 1, down 3, left 1. Okay, and this will be a solid line because what we mentioned earlier. Okay, so here is that line, and that's line number 2. Okay, now I'm going to do some shading. Okay, so let's look at that first. Go back to line number 1 again. Okay, and we're going to test the point 0, 0 to see if that point is true for this line. Okay, so here's equation number 1. I'm going to plug in 0, 0. So 0 is greater than -4 times 0 minus 7. So 0 is greater than, this goes away, -7. Is that true or false? That is true. Okay, so I will shade on that side. So this is 0, 0. So I'm going to shade this side of the dotted line. Okay, so all of this stuff, all of this gets shaded. Okay, so that's for line number 1. All of that gets shaded. Okay, now let's look at line number 2. I'm going to test 0, 0 again, but I'm going to do it in number 2 now. It's this one. So 0 instead of y is greater than or equal to 3 times 0 instead of x plus 2. So 0 is greater than or equal to, this goes away, 2. Is that true or false? This one up here was true, but this one down here is false. 0 is not greater than 2. So I tried this side of this solid line, 0, 0, and it turned out to be false. So I cannot shade this side. I have to shade the other side of the solid line away from this point. So over here, the other side of the line, I'll shade that one in purple. Okay, so here's a little bit that gets shaded down here, and then all of this stuff that was already shaded blue that's on the right side of this line gets shaded. Okay, so what got shaded twice? Well, this didn't get shaded twice, so that's not included. This was only purple, this was only blue, This got no shade at all. So the only part that is included in our solution set, and I'll do that one in red, is this part. To the right of this line, all of this stuff, all of this gets shaded right here. So everything in red is my solution set. Okay, the stuff that's just blue is not, the stuff that's just purple is not, and the stuff that wasn't shaded at all is not. So that is my solution to that one. Okay, let's take a look at one more. So we've got y is less than negative 2x minus 9. Okay, and then y is greater than or equal to 2x minus 3. Okay, so our slope, which I'll call m on this one, is negative 2 over 1, which could also be written as 2 over negative 1. And our b is negative 9. On this one, our slope, which I'll say is m, is 2, I'll put over 1. Could also be written as negative 2 over negative 1, because negative divided by negative is the same thing as a positive, right? Okay, so that is a 2, by the way. Kind of hard to read. And then our b is negative 3. Our y-intercept is negative 3. Okay, so let's graph these. Remember about the solid and the dotted lines. This has no line underneath, so it'll be a dotted line. This whole line will be a dotted line. And this one has a line, so it will be a solid line. Even put that there if we want. So this one is dotted, and this one is solid. Okay, we'll call this line number 1 and that line number 2 to keep ourselves organized there. Okay, so let's graph the first one. We go to negative 9 on the y-axis, that's here. Okay, and use the slope down to right 1. Down to right 1 goes here. That's it. I can't go any further that way. Let's use the up to left 1. So up to left 1, up to left 1. It's right here. Hopefully I get all these. There we go. Okay, so just use the slope over and over and over again to get all those points. And it's a dotted line. So there we go. Okay, so that's line number 1. Now for line number 2. Okay, so we start at negative 3. That's right here. We use our slope of 2 over 1. So up 2 over 1, up 2 over 1. That's here. And we could also use down to left 1. So down to left 1 would be here. Okay, and this is a solid line because of the inequality. There is an equal to down there below it. So this is what this line looks like. Okay, and this is line number 2. Okay, so now we need to figure out which to shade. So I'm going to do exactly what I did last time. I'm going to pick a number that's in a region for both of these. 0, 0 is always the best one to try unless one of your lines goes through 0, 0. So let's test 0, 0 in both of these. So test 0, 0. So for the first one, it would be this. So instead of y, it's 0 is less than negative 2 times 0 minus 9. This goes away. So 0 is less than negative 9. Is that true or false? False. 0 is not less than negative 9. Okay, so for this dotted line, line number 1, okay, I tried this point and it said, nope, that didn't work. So instead of shading over here to the right of the dotted line, all this stuff, well, since it didn't work, now I have to shade over on the other side. Okay, so I'm going to shade this stuff over here. Everything that is left of that line, everything that's not on the same side as this. So all the stuff over here of the dotted line. Okay, let's look at the second one. We're going to test 0, 0 again. Okay, so that's for the second line. I'll get 0 instead of y is greater than or equal to 2 times 0 minus 3. Okay, this goes away. So 0 is greater than or equal to negative 3. Is this true or false? Well, it's true. It's not equal to negative 3, but 0 is certainly greater than negative 3. So this is true. Okay, so for line number 2, the solid line, I tried this point 0, 0, and it turned out to be true. So that means everything over here gets shaded. Okay, so everything on the left of that line gets shaded. So I'll use this purple to shade the solution set of line number 2. Okay, so once I do that, what I'm looking for is where did I get double shaded? Where did I get double shaded? I did not get double shaded here. I did not get double shaded here. And I did not get double shaded in this little triangle down here. Where I did get double shaded is all that area. So you can leave that alone, or I'll paint it red real quick. Okay, and there's my solution set. And that's it.